Good afternoon, guys. Now we're going to discuss about loading in Baton Rouge, Mississippi, in Louisiana. Uh, this is a continuation to our last video. Now, in our last video, we we computed uh, on our arrival in Panama of Even Keel, and we computed what will be our departure in Baton Rouge and what will be the trim in departure of Baton Rouge to arrive Even Keel at Panama. This time, we're going to actual compute until uh, we will uh, we will have a departure drop in Baton Rouge in Louisiana or in New Orleans. Uh, we will have a departure drop and we will arrive uh, Even Keel in Panama with using the water density or in Panama and Baton Rouge. So let's start, guys. Okay. In our last video, we 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 computed how much will be our departure drop in Baton Rouge in going to Panama to arrive at Even Keel at 13 meters. So in our previous computation, our departure drop in Baton Rouge will be forward will be 12.927 and up drop will be 13.027 with a mid drop of 12.977. So that's in a Baton Rouge. This one. This time, we will depart in Baton Rouge going to Panama. But here, this is an actual loading. So we have a target drop for departure. So let's say uh, our vessel is a 7 cargo hold vessel, so it is a Panamax. So this is a 7 holds vessel, so this is what we call the Panamax. So we are going to load in Baton Rouge. Okay, so this is the program that we are going to use to arrive in Panama of Even Keel of 13 meters. So for example, now we are loading in Baton Rouge, and we have a target drop forward of 12.927, an updraft of 13.027, and our main drop or our departure drop, maximum departure drop in Baton Rouge is 12.977. So we have a trim of 10 centimeters. So you will advise the foreman. They say, foreman, this will be our maximum draft, sailing draft. Mid will be 12.977 and our fore draft will be 12.927 and updraft will be 13.07. So we should have a target drop, target trim of 10 centimeters. Okay, so bear in mind that you should you have a target of this drop forward and up and your trim and your mean. So as the title says here of our program, how to find drop and trim when handling weights involving large changes of mean drop, meaning large changes in mean drop, meaning adding weight or uh, taking out weight. So let's explain this procedure. It says in number one, you have to put your you have to input your departure drop, forward, and up drop, and mean drop, and trim. So you put your density in Baton Rouge where you are going to load. So in number two, from the hydrostatic table, is number two, uh, you get the LCF of this drop, this main drop, which is 12, 12.977. So to get this LCF in number two, so you have to interpolate and find the drop of 12.97. You have your LCF is 1.023, which is this one, interpolation. I'm sorry. LCF is 0.103, which is U12. It is in between 12.8 and 13 meters, so it is in between here. Okay, your LCF. LCF. So you have to interpolate to get your LCF. Okay, it's 1.03. Okay, and we proceed. We go to number three. You compute for your mid center of rotation. So by this formula, trim times LCF over LPP plus your mean drop, you will get your mid LCF, which is 12.977. Okay, so which is to make a shortcut, you add forward and up drop, divide by 2, then you will get your mean drop or your mid center of rotation. In number 4, this is number 4, you will look for your value of LBC, MTC, and displacement of 12.977. So what is the displacement of 12.977? Displacement of 977 is 76805. 76805. And your LCB is negative 6.81. LCB is negative 6.81. Your MTC is 976.9. MTC is 976.95. So this is interpolated between 12.8 and 13 meters. Looking at the hydrostatic table, so in between this figure 12.8 and 13 meters, you will have to interpolate the value of the TPC, MTC, LCB, LCF, and displacement. So in short, you have to interpolate these figures. This is what it looks when you interpolate to get this value of these figures, the displacement, LCB, and MTC. Okay, then we go to number 5. What is your initial LCG? To get the formula for to get the initial LCG is this one. Trim times MTC times 100 over tabulated displacement. This is your tabulated displacement. Your trim is 10 centimeters. This one, 10 centimeters. And your MTC is this one, 976.9 times 100 over tabulated displacement. Plus LCB, this is your LCB is negative 6.81, and the value you will get is negative 6.6854245. Okay, that is in number 5. And what will be number 6 is looking for initial displacement. So this is your tabulated displacement. Now we are looking for the initial displacement. It says here, number 6, correct the displacement to the true displacement, initial displacement, by applying the effect of density. So because you are floating at density 1.00, so you will get the value of the displacement by applying the density or your local density. So the formula for that one is tabulated displacement, which is this one, 76805, times your local density, DD. Local density or your dock water density is this one, 1.000, and divide constant of 1.025. By way of this formula, the initial density would be 74931.363. Okay, so initial displacement would be this value, 74931.363, and your LCG, which is this one. Initial LCG is negative 6.68542, and LCG moment is weight or the displacement times LCG is your LCG moment. So multiply this one with LCG and you will get an LCG moment. Okay, then we go to number 7. Find the ship's displacement, final displacement, and total LCG moment by final CG after loading or discharging the weights, meaning you apply the weights that you have consumed or added. So in our previous video, we have a total consumption of 227 metric tons in FOT, fuel tank number 4 center, and our total consumption is 50 tons of freshwater in freshwater tank starboard, and we have a production of 75 tons in freshwater tank port side. So since we are going we are going from Baton Rouge to Panama. So we had a total consumption of fuel oil is 227 metric tons, and a consumption of we have production of 75 tons and freshwater, and we have consumption of freshwater of 50 tons from Baton Rouge going to Panama. Okay, so since we depart from Baton Rouge, so we have a consumption of fuel of about 227 metric tons in fuel tank number 4 center. So consumption meaning we have to put negative sign because we're going to consume. And we have a consumption of fresh water of 50 tons in freshwater tank port side, and in starboard side we have a production of 75 tons. Okay, so we do the computation. uh, by way of computation, your final displacement, this initial displacement, you uh, minus your consumption of fuel consumption, minus your freshwater consumption, plus your production of freshwater. This will be your final displacement. So with your LCG, so LCG will be, your final LCG will be negative 6.80018, and this will be your LCG moment, total LCG moment. Okay, and we go to number 8. uh, what will be your final LCG? So final LCG is say total moment, LCG moment, which is this one, total LCG moment over final displacement, meaning this one negative 508,173 divided by your displacement. Final displacement is 74729.363 is your final LCG. Okay, and in number 9, you will apply now the density in Panama. Okay, now in number 9, correct the final displacement to look up displacement due to the effect of density to the main graph. So look up the final density, final displacement, and multiply. So to look up the displacement equals final displacement times the constant of 1.025 over your local density. So the final displacement, this is the final displacement times your constant of 1.025 over your local density, and the value of your lookup displacement will be 76951 metric tons. This will be your lookup displacement for this density. So how do we apply that in our, look at this one. This is the displacement of the value that we are looking for, 76951.74. This one, 76951.57. Okay, that will be 57. Okay, so what will be the value of this when we apply this formula? Final displacement times constant of 1.025 over the local density of 0.9 954. The value will be 7695157. Okay? This the answer to this formula is lookup displacement is 7695151.5. What will be the draft of this lookup displacement? So we'll see. Look at here. I will take erase this one or take out. So we don't know what is the draft for this value of and the displacement uh, value of this displacement. What is this draft? What will be LCB? What will be LCF, TPC, MTC? So with this figure of lookup displacement 76951.57, we'll put it inside here. So we put equals here, then click this one and enter. So there she goes, 76951.574, which is this one. So the value of this displacement will be 13 meters, and the LCB of this displacement is negative 6.80, and the LCF will be 0.12, TPC will be 6.30, and MTC will be 977.50. And so the value of this displacement will be 13 meters, and you will put here the value of this 30 meters LCA will be 0.12 LCF 0.12, and your TPC is 64.30. TPC is 64.30, and your LCB is negative 6.80. LCB is negative 6.80, and MTC is 97750. MTC is 97750. Okay. So this will be your mid-draft. This will be your mid-draft. Okay. And number 10, you will compute what will be his final trim. So number 11, the final trim is LCB minus LCG minus LCB times corresponding displacement times MTC times 100. Okay? This is the formula for getting the final trim. This one. So what is your LCG? LCG is this one. Final LCG. Negative 6.801767 minus your LCV minus this one, which is almost the same, times corresponding displacement times your displacement, this one, 76951.67, and over MTC over 977.50 and times 100. The value of this formula will be, your final trim will be 0.00, meaning there's no trim, even keel. So in short, because you have no trim, which means to say that your forward draft and aft draft will be 13 meters, the same. And this is your mean draft, so meaning forward and aft draft and mean draft will be all 13.0 meters, which is this one. Okay? But for the sake of computation, To get your forward change of draft forward, this will be your formula. LPP, which is 215, LPP, which is 215, over 2 plus your LCF plus LCF divide LPP, which is 215, times final trim. This is your final trim, and the answer would that forward draft will be 0, and your draft out is final trim. This is the final trim minus your forward change of draft forward is will be your updraft. This formula won't be necessary because your trim is already nil or 0, meaning to say your forward draft would be 13 meters and your updraft will be 13 meters. So with your main draft, because you have no trim. Because with this lookup displacement, the value of this one is 13 meters. Okay? So you have a 0 trim. So by reviewing this video, and you start from item number 1 going down to item number 13, you will arrive at the draft forward of 13 meters, updraft of 13 meters, and mean draft of 13 meters. So this is one way of checking if your computation would be correct when you are using this formula. If what will be your departure draft in New Orleans or in Baton Rouge if you want to arrive 13 meters in Panama. So it's the reverse. From here, you start from Panama to going up to Baton Rouge. You will compute for the departure draft in Baton Rouge. Forward will be 12.927 and updraft will be 13.027 with a mean draft of 12.977, which is this one. But on the other hand, you will ask or you will tell the foreman that, foreman, this will be my departure draft here in Baton Rouge. Forward will be 12.927 and my updraft will be 13.027 and my mean draft will be 12.977, mid or mean draft. So when I get this target drop, and I should have a trim of at least 10 centimeters. So with this drop, you apply your fuel consumption, which is 227, which is negative, and you have a freshwater consumption of 50 tons, and you have production of 75. Until you arrive in Panama, even keel of 13 meters, forward, aft, and midship. So that's it, guys. With this program of how to find weights and trim when handling weights involving large changes in mean draft. So you have to apply your density, departure density, and your arrival density. Not unlike in form number 6, here in how to find trim when handling several moderate weights. Here you don't apply your density here. You just put on the weights and he will compute your final draft forward and up, because your you're actually using the draft at the very moment when you are loading the trimming holds or the trimming cargoes. Okay, this one. So you don't need this density. Not unlike this one, you apply your local density in your departure berth and your arrival berth in Panama. So you have to apply the density also. So that's it, guys. I hope you will like it. And if you have any questions, please make a comment on the comment section. And if you please like, share, and subscribe. Thank you very much and have a good day.